Today I'm going to go over some things from Chapter 8. So this is Final Exam, Part 2. And I'll try to review all the things that you'll need for your exam for questions 16 through 30. So first off, in Chapter 8, we talked about varies problems. And varies, we have a direct and we have an indirect. So if we have words like y varies directly with x, we'll have this type of problem. And if we have a y varies indirect or varies inversely, we'll have this type of problem. So remember what you have to do. You have to first translate. Then next you have to solve for a. And then third, which a lot of you forgot, is you need to rewrite. So if you solve a equals 0.6, then the rewrite for final answer is y equals 0.6 times x. We also learned how to graph rational functions, and there were two types of graphs. A y equals a number over a variable, and a y equals where we had a variable in the top and the variable in the bottom. Okay. So let me just talk about some general points of these, and then we'll graph them. But basically, for domain and range, if we have a number in the top, the domain will be all reals except when the denominator equals 0. So this will be except when x equals -1. Domain, if we have a variable on the top and the bottom, again, will be all reals. But when the bottom doesn't equal 0, set this equal to 0. Throw the 8 on the other side, divide by 7. It would be when x equals 8/7. Okay? So remember, when we're graphing these things, this is where the vertical asymptotes are. Okay. And again, make sure that you're copying these notes down at the same time so you can understand what's going on. The range are what y can't equal. So if there's a number on the top, it's all reals, but y can't equal 0. So that's the horizontal asymptote. And when we have a variable on the top and the bottom, it's all reals. But when we have a variable on the top and the bottom, remember, we look at the coefficients in front of the x. So our horizontal asymptote will be these values. So 5/7. Now when I go to my calculator, just remember a big thing about graphing this in your graphing calculator is to make sure you have parentheses around both of these. Okay. So I'll do a quick sketch for 5/. Again, make sure you put the parentheses in there. Punch with me so you can get an idea of what's going on. We have our asymptotes, so we can do a quick sketch for number 2 in this example. When you punch it on your calculator, make sure that you put parentheses in the top and then parentheses on the bottom. You get the basic shape of these. On your exam, you'll need to graph and state domain and range. The next part of Chapter 7 was simplifying, and we just had some basic factoring rules here. So if we have a squared minus b squared, how does that factor? An a minus b and an a plus b. So if I had an x squared minus 64, this would factor to an x minus 8, x plus 8. If we have a 4x squared minus 9, this is a perfect square, and so is this. So it would factor the square of 4x squared is a 2x and a 2x. To get 9, I do a 3 and a 3. One's positive and one's negative. So when you're asked to simplify, if I have an x squared minus 81 all over 36x squared minus 16 times x squared plus a 10x plus a 9 all times, we factor first. Remember, we can't cancel out when we have plus minus lines, so we have to factor. And anytime that we have the same factor on the top and the bottom, then we can cancel. So x squared minus 81 would be a plus 9 minus 9. Here we get a 6x minus 4 and a 6x plus 4. X plus 1 we can't do anything with. What are the factors of 9 that add up to 10? 9 and 1. Now, anything that's on the top and the bottom, we can cancel. What we have left is our final answer. So basically, this reviewed our factoring pieces. There's a couple different ways to factor. If we have a factor of two terms, difference of two perfect squares, we just factor like that. If we have a factor of 3 terms, we look for the factors of 9 that add up to the middle term. If we have things where we only have 2 things, we look to see if something's common. So we see a 2 common here, and they both have an x squared. So we factor that out. And then on the bottom one, this was a little bit more complex. What are the factors of negative 6, y negative 6, that add up to negative 5? So we'd have a negative 6 and a plus 1. So we get a 2x and an x here. And then we need a minus 3 here and a plus 1. So let's check this. 2x squared minus 6 plus 1 is a minus 5x, and a positive times a negative is a negative 3. Okay, so that was our first step. And then again, if we have the same factor on the top and the bottom, we can get rid of that. The second type of problems that we had with simplifying were when we had all multiplication. So the rules are a little bit different. When we have all multiplication, what we're going to do is just rearrange. So I suggested that you put your numbers together, all your variables that look the same together, and then take that and simplify that individually. Okay, so 5 goes into 15 3 times, 2 goes into 10 5, 2 goes into 4 2. So this would simplify to 5 6. If we have more x's on the top, we'll cancel and make that an x to the 6th. Here we have 6 y's and a y on the bottom, so that'll give us 1 y on the top. And here we have more z's on the bottom, so when we cancel that, the z to the 5th will be on the bottom. Okay, so you'll see these all kind of together in one fraction when you simplify. When we have a multiplication of 2 rational functions, we want to factor. Then we can cancel out. So if here's our difference of 2 perfect squares again, so we have x and x, a positive 8 and a minus 8. Here we have the factors of 16 that add up to 10, which are 8 and 2. Once we factor, then whatever's on the top can cancel with what's on the bottom, and our final answer would just be this. Dividing has a different set of rules. So if we're dividing a rational function by another function, the rules are we factor the first, and we change division to multiplication, and we flip this fraction. We always flip the second fraction. Then again, there's our difference of two perfect squares again. What are the factors of 10? That add up to -7. If we have the same factor on the top and the bottom, whatever we're left with is our final answer. Adding and subtracting, we have the rules are we need to get a common denominator. So the easiest common denominator is to multiply the denominators together. And then I need to change this fraction to look like this. So this needs an x minus 9. Distribute. This has an x minus 9. It needs an x plus 9. Distribute. And add up like terms. So here we'd have our common denominator. Our tops, we'd have 11 of these, and -63. -63 plus 36 will end up to be a -27. Subtracting is the same rules. Get a common denominator. So we could multiply the denominators together, but let's look at this fraction. This fraction is an x minus 4, x plus 4. So I think I can make this fraction look like this. So my common denominator is going to be x minus 4, x plus 4. So I don't have to do anything with this fraction. Okay. In order for this fraction to look like this, it needs an x plus 4. And then be careful with subtraction. So we've got to, maybe the best thing to do is add the opposite. So we get a -3x and a -12. Combine like terms again. This time we'll have x minus 12. This is our common denominator. You might see it written like that. We ended chapter 12 with a solve. And our solve problem here can be written 4x over 3, and we solve by cross multiplying. So we get 4 times x minus 6 equals 7 times x plus 3. When we distribute and solve, we put the x's on one side, the numbers on the other side. So we get minus 45 equals 3x, or x equals -15. Okay, it's always a good thing to plug that back in and check your answer. This is the end of chapter 8 review, and this should get you through 15 through 30 on your exam review.